now let's talk about some statistical methods that are available within Pandas, especially for series objects and data frames. And there are many basic statistical measures that are available. And if you have worked with data before, you will see that the sum is sort of the most basic one of them. So in Pandas, you can just call the .sum method on your series and it will print out its sum. So you see song66 sum. Let's print the original song66 for better comparison. Okay, just a sec. So yeah, you can see 3, 11, 14 and 9, 23. So if you don't want to skip null values, which it does in default conditions, you can provide the parameter skip NA to false. And if you do that, it will give you the sum as NaN, because anything added to NaN is NaN. There are a few other standard basic methods available in statistical terms, which is mean of the series, then the median of the series. Then you can get the quantile of the series as well. 50% is the default value here, but you can pass a float value. So if you pass 0.1, you will get the 10th percentile. If you pass 0.9, you will get the 90th percentile. If you want to get a good overall feel for the entire series object, there is a method called describe, and it presents a good number of summary statistics and returns the result as a series itself. It includes the count of values, their mean, standard deviation, minimum, maximum, and the 25, 50, and 75 percentile quantiles by default. So let's see it in action. So you can see, as I said, for this particular series, it will give you the count for the non-null values, their mean, their standard deviation, minimum, maximum. They are 25, 50, and 75% quantiles. But you can change that if you want specific quantiles as well by providing the percentiles as a list of float values. So you see, it will now give you 5%, 10%, 20%, and 50% by default. You can also get the minimum and maximum directly by using .min and .max. But if you want the index of the value minimum, so you want to know at which index does the minimum value occurs, you can use idx min. The same applies for idx max. You can get the variance, standard deviation, and mean absolute deviation as well by using these var, std, and .mad directly as well. So it depends on the use case. If you don't want everything all together, you can use these individual methods. But as you can see, all of this is available in describe as well, except the mean absolute deviation. So that depends on your use case. So now let's talk about converting different types into different types within Pandas series. And if you're not aware that, then let me tell you that the series object has the ability to tweak its values. The numerical values in a series can be rounded up using the round method. Then there is astype method available that converts values to different data types that are passed in. And if there is a method that is invoked on converted values, let's say you convert some integer values to a string value, then you can use a method that is invoked on those converted string value, and there might be a possibility that it does not give you the desired output. So please remember that things can go wrong. So let's see an example of that itself directly. So if we do rounding off for song66, which we actually did not need to do, so just as an example for you guys, now what I do is I convert the type from float to string. So all these are string values now. Now let's say if I want to get the maximum, and since we know that the maximum should be 11, but it's giving NA because lexicographically this is the largest value or the maximum value present in this string. So just be aware that when you are using this astype method, that converting from one data type to another can have some repercussions, some problems. So just be aware of that when you're using these things in practice. And by default, there are some functions that are available in Pandas that cannot be used directly because they cannot coerce with the data. So let's see an example of that, what I'm trying to say. So if what I'm trying to do is I'm using the Pandas toNumeric method to the applied string converted song66 series object. So let's see what happens. We get an error, and what is the actual error? It's unable to parse the string NaN because it cannot convert NaN to numeric. So please be aware that sometimes these things can happen where the data can't be coerced from one data type to another. That's why the method like fill NA is quite handy, or to see what your data actually has, to see its statistics as well, can come in handy. So now let's talk about how you can deal with null values in a little bit more of a detail. So the NaN value is usually disregarded in calculations, but sometimes it's useful to fill them with another value or to identify how much of these null values occur in your data, or do you really want to do something else with the null values rather than just filling them with another value, or there might be some cases when you want to drop the null values altogether. So in this case, let's start by filling the null values with -1. So you see, for Ringo, I filled it with -1. Then we can drop it as well from the series in altogether, and you see the null value for Ringo was dropped entirely. And please be aware that, as I said in the beginning as well, all these methods have in place and copy parameter available to them. So by default, in place is false, and that's why a new series object is returned every time, and copy is true. But you can set in place equal to true or copy equal to false to get a same modified series or data frame object. So there is another way to get the non-null values or non-NaN values by using something called a Boolean mask. So the not null method gives us the Boolean mask, and to get a mask for null values we can use is null. So let's see it in action. So I have created a mask, and this is the mask. Now I apply this mask to my series, and I only get the values where the value was true in the mask itself. And this was for not null case. Now let's see what happens for the null case. I see all these false values, one only true, and then I can apply this to my series object and see what happens. But there is also one thing to keep in mind, that the masking with the Boolean masking is not limited to only null or not null values. You can have your own different Boolean mask that you can use. So let's see one other example to show what I mean. So I have an NaN mask which takes the null values, and I can invert it by using the ampersand, not the ampersand, the tilde. And if I apply this mask to my original series, you see the same result as we got to the original not null mask here. So now let's talk about some matrix operations that are available in series objects. So computing the dot product is available through dot method, but this method fails if there is any null values or NaN values in the series, and removing NaN will give a value for the dot method. A series also has a transpose method or a dot t method. So let's see them in action. So let's see, this is our original series objects where one null value is present, and if I try to do a dot method product, it gives us NaN because there was null value present in one of the series. So what I do is, now I drop the NA values in one of the series where it's present. I know it's not necessary, so let's remove it. Sorry, yeah, it's 66 only. I was assuming 69. My mistake. So now you can see when we drop NaN values, we can get the numeric value for the dot product. Then you can transpose your series as well. Doesn't look like much because it's a series object, it's a one-dimensional object, so it doesn't change much. But if you had a data frame, then it will switch the rows and columns. So assume you have a matrix where you have certain rows and certain columns, and that applies to a data frame directly. So if you use this transpose method using either dot t or dot transpose, you will have the actual transposition that you are used to in normal matrix calculations. Now let's talk about the next set of methods, which are appending, combining, and joining two series. So to concatenate two series together, you can just use append method, and this takes another series as a parameter. And this method creates duplicate indexes by default, but an optional parameter called verify integrity is available as well. And when it's set to true, it will complain when indexes are duplicated. So let's see what I'm talking about. So when I appended song 69 to song 66, you see that my indexes are repeated and the values are added. But if I apply a verify integrity equal to true, it gives me an error, and it says that indexes have overlapping values for these 4 indices. So another method that we have available is combine, and we use this method to perform element-wise operation on strings, and it takes another series and a function as its parameters. So I've created just a simple simple object for average, where it takes in 2 values and divides it by 2, their sum of it. And if I apply this combine method and add the series is 66 and 69, let's see what happens. So what it does is, it takes the values from the first series and the second series and passes it through average and gives me that value. If you're not sure, just go look at the original values and do the calculation yourself. You'll find what I'm talking about, it's true. And then if you want to update your one series values from the another series values, so for example, you want to update song 66 values with the song 69 values, you can do that so by using the dot update method. And then we have a repeat method as well, which repeats the same series the number of times, which is passed as integer in the parameters. It's similar to multiplying a scalar value to a list in Python. So you'll see it will just multiply that series with the number of times it's present in the parameter. So if I pass 3, it will do the same for 3. So now let's talk about the sorting methods that are available in Pandas series. So you have sort values, sort index, and rank. So let's discuss one of them, each of them in detail. So sort values returns a new series sorted on the values, and this method also supports something called ascending. So by default the ascending is true, so it will give you the sorting in ascending order. So as you can see here with the values, but if you can want in descending order, you can pass ascending equal to false and you will get that in descending order. You can do the same for indices. So you have sort index where indexes are sorted ascending. You can pass index ascending equal to false to get the indexes descending. And there is another useful sorting method which is related. It's called rank. This method ranks the indexes by the values of the entries, and it assigns equal weights for ties, and it also supports for ascending parameter to reverse the order as well. So if you see it in action, you see that George is 2 because it is the second value in the ascending order. Ringo is 1, then John is 3, and Paul is 4. Now if we want to apply, let's say, custom methods to our series objects, we can do the same as well in Pandas. So let's see that in action now. And this can be used to alter, clean, check, or apply any arbitrary function. We do this by using the map method that takes a function or a dictionary or a series as a parameter and apply that to each element of the series, just like Python, the map method. So here in this particular case, this format method, what it does is, if it finds x equal to 1, then it gives the value returned with song attached to it, or if it's greater than or not equal to 1, then it gives songs. So just a singular and plural check there. And if we apply this to song 66, so you can see it adds songs to the values. And you can add directly a dictionary as well. As I mentioned, that map accepts either a function, a dictionary, or a series directly. So it's a dictionary where I'm mapping 5 to none, 18 to 21, and 22 to 23. So let's see what happens. Since 5 was present, it mapped it to none, and 18 was present, it mapped it to 21, and 22 was present, it mapped it to 23. But for Ringo there was nothing present, so it marked it as NaN as well. Now let's see the third case where I'm passing in as a series object directly in the map method. So you can see it will do or create null values for all the series objects or series values that are not present in the series that is passed. There is one thing to note here. There is an apply method available in the series object as well, and it behaves very similar to map object, but it only works with functions, not with series or dictionaries. So for example, let's see it here. So I can use the apply as well, and it will give me the same results. But if I try passing in a dictionary, it will surely give me error. Yeah, as you can see. But you can create your lambda functions directly here as well. So for example, let's just increase the values by 1. So yeah, as you can see, all the values are increased by 1. Now let's look at some string operations and that are available for series objects. A series that has string data can be very easily manipulated by vectorized string operations, and to invoke such string operations, simply invoke them on the str attribute of the series. So we are going to work with this series now, where it's just 3 indices, 3 values with indexes 0, 1, 2. Because we did not provide index, it takes indexes monotonically increase integers from 0. And since I passed in names.string.lower, it lowered the casing of the values, and I can apply this find all as well. So it will try to find where this O is present in all the values. So you can see it is present in the 0th index, 1st index, but not on the 2nd index, as you can see here as well. So these are a few of the string methods or vectorized string methods that are similar to Python, and they're applicable on Pandas series. So it contains matches, Boolean result, count, pattern occurrence count results, and all these. You can have a look at them and try out them in detail based on your different use cases. I'll show you some examples. So this is our actual new series that we created. So if we apply the len or length, it will give us the length of the strings, and then if I apply, let's say, upper, it will change it to uppercase. I hope you got to learn a lot from it, and I am sure it did not cover all the methods that are available in Pandas series or Pandas data frame objects for that matter, but the ones that I've covered are sort of the most used ones or most needed ones when you're working with data. So if you have these, at least I'll not say mastered, but If you have some hands-on with these methods, then you will save a lot of time by being efficient rather than not Googling everything. I'm not saying that Googling is bad when you're working on something, but just to be a little bit more efficient and to remember that, okay, this can be done in a better way within the Pandas framework that is available. So yeah, that's the goal. And I'll see you again next time in the next video. This entire Jupyter notebook will be available in the link in the description box on my GitHub. So you can check that out as well. And if you have any questions, just feel free to reach out to me in the comments. Have a good day.